Okay, we're starting chapter 8 here with something that is going to be reviewed for everybody, ratios and proportions, and this is probably one of the most applicable math topics in the real world. So I'm going to be integrating some of that into the chapter along with the geometry that goes with it. Um, Ratio proportions are great because you can use them for conversions, uh, things like every day if you have a recipe and you need to make it larger or smaller, okay, that involves ratios and proportions. So this is a very important topic in everyday life as well as geometry. Um, so we're just going to start with some definitions. Ratio is just a comparison between two numbers, okay, and we can write it in different ways. But so a ratio is a comparison of two numbers or measurements and usually if you're going to be comparing measurements, these have to be in the same units in order to compare them. If they're not in the same units, then your ratio is going to be wrong, at least if you start trying to reduce them. So there's different ways to write ratios. You can write it with a colon like this, A to B, the ratio of A to B, or you can put it in a fraction. This is the most useful because this is what we're used to, using fractions. This is still the same thing as A to B, the ratio of A to B, or you can write out in words the ratio of A to B. A proportion is an equation that equates two ratios. So an equation, which means there's an equal sign, that sets two ratios equal. So if you have a fraction equals a fraction, fraction equals fraction, that's a proportion. So here's a proportion, and we're going to label the different parts here. There's two parts. There are the means and the extremes. Okay, now if I was reading this, I would say A over B equals C over D. So extremes would be the ones that I read first and last, okay, because those are the extremes of my statement. So the very first thing I said was A, and the very last thing I said was D. Those are the extremes. The means, average or middle, okay, mean is a type of middle, so those are the ones that are in the middle, okay? The ratio of A over B equals C over D. The two that are in the middle are B and C. Those are the means. Okay, and it's important to know this because there's going to be some properties that are described in terms of means and extremes that we'll get to eventually. So our first property is a cross product property. This is just what allows you to cross multiply, and that's exactly what the property is. Cross multiply. Okay, so if I have a proportion, okay, what you can do is the product of the means equals the product of the extremes. So if I go back to my A over B equals C over D, the cross product property is what allows me to say AD, so A times D equals BC, B times C. I'm multiplying the extremes and setting equal to the means multiplied together. Another property is the reciprocal property. Okay. If I've got A over B equals C over D, then I can reciprocate both sides of my equation. Okay, just like I can multiply both sides by 5 or subtract 3 from both sides. Reciprocating is another thing that you can do to both sides of an equation. So I can say B over A is still equal to D over C. And we can verify this with our cross product property, because if I multiply these, I get AD equals BC. If I use a cross product here, I get BC equals AD, and these are equivalent expressions, or equations actually. So we're going to be using these properties not only in this chapter, but in our next chapter to help us solve proportions, because proportions are what we're going to be using for a lot of the rest of the year. So let's look at another application of some ratios. So ratios in the real world are usually used for converting things. So a conversion factor is a ratio that is used to convert quantities from one unit to another. So an example of this conversion factor is, all we need to know is a simple fact about a certain unit and how it relates to different units. So I'll use one that everybody knows. There are 12 inches in 1 foot. So a conversion factor is a ratio. So I'm going to make a ratio out of these quantities. 1 foot over 12 inches. This is a conversion factor. Another one I can make with the same equation would be 12 inches over 1 foot. And we're going to use this in dimensional analysis to convert units. So dimensional analysis is the process of using conversion factors to cancel units and change units. So I'll do another example. I'll use this same thing. I'm going to put another conversion factor in here. Okay, 1 yard equals 3 feet. So I could have 1 yard over 3 feet, or I could have 3 feet over 1 yard. So dimensional analysis, a dimensional analysis problem would be like this. Let's say I'm traveling at 40 yards per minute. Okay, per means divide. So every 1 minute, I'm traveling 40 yards. Okay, so this is how you would write speed. Now what I'm going to do is I'm going to set up some conversion factors that allow me to change this. I want this to be in inches per second. So I need to convert from yards into inches, and I need minutes to change into seconds. So we're going to use fractions, and knowing that in a fraction, let's say I have 2x over 4x. Okay, if I have x on the top and bottom, they cancel. And that's the fact I'm going to be using, only I'm going to be using it with my units. So in order to cancel yards, because when I'm done, I want just inches on top. So I don't want yards, so I'm going to have to put yards on the bottom. And what do I know about yards? I know that 1 yard is 3 feet. So 1 yard is 3 feet. I'm going to put it in that order because now yards, the unit yards, cancel. Feet, I don't want feet, I want inches. And what do I know about feet? Well, I know that 1 foot is 12 inches. Now feet cancel. So I've got inches on top, which is what I want. Now I need seconds on the bottom, but right now I have minutes on the bottom. So in order to cancel minutes from the bottom, I need to put minutes on top. And what do I know about minutes and how they relate to seconds? 1 minute is 60 seconds. Now minutes cancel because I have 1 on top and bottom. So if I look here, I've got inches left and seconds. That's what I want. So now I'm just going to do the math. 40 times 3 times 12. Okay, and that would be 1440. Yep. Over 60. And I can reduce this. Okay, the zeros will cancel. So I got 144 over 6. 144 is really 12 times 12. 6. I can rewrite this 12 as 6 and 2. The 6 is canceled, so I've got 12 times 2, which is 24 inches per second. And that's a version of dimensional analysis, which you should have been doing in science class also. So here's some other examples. Use the known information to write 2 conversion factors. These are the type of things that I'll have you do in your packet. 1 cup, 8 ounces. That means I can write 1 cup for every 8 ounces, or I can write 8 ounces for every 1 cup. How many ounces are in 5 cups? Well, if I have 5 cups, I want to convert that to ounces, so I'm going to put cups on the bottom, 8 ounces on top. That means it's 40 ounces. How many cups are in a 16-ounce can? If I have 16 ounces, I'm going to want to cancel those with ounces, so I know there are 8 ounces in 1 cup. Ounces cancel. 16 over 8, 16 cups over 8 reduces to 2 cups. So here's some other examples you have to be doing for just the basic stuff. Simplifying ratios. You kind of saw me doing this with the dimensional analysis, but you're just taking out common factors is what you're doing. So you could think of it this way. I can divide both of these by 6. Okay, which means I'll have 3/4. So another way you could do this is just to write out the factorization of each number. 18 is really 9 times 2. 9 is 3 times 3 times 2. So it's kind of like when we break down radicals. 24 is 6 times 4. 6 is 3 times 2. 4 is 2 times 2. And then you just cancel out the things that are the same. Okay, so this is a prime factorization. And that's the easiest way to cancel things. Because now I've got 3 on top, 2 times 2, which is 4 on bottom, and I get the same answer. So either way is fine. If you're reducing things that have different units, you have to first convert them so that they're the same unit. The metric system is going to be used quite a bit. So you might want to make a note about the metric system. It goes millimeters, centimeters, or grams, or whatever your units are. And then it's deci. And then it's your base unit. And then it's deca, hecto, kilo. Okay, so if I'm in meters, that's what's here. This is This is meters or grams or liters, whatever your base unit is. If I'm moving this way, it's going to take 10 of these to be one of these, 100 of these to be one of these, 1,000 of these. It's always increments of 10, which is why the metric system is so fantastic. So 1 meter, if I want to convert that to kilometers, I would have to move the decimal place 1, 2, 3. Okay, but then I would have a decimal, and I prefer not to have decimals, so I'm actually going to convert kilometers to meters. So I'd have 2 kilometers would be 2,000 meters. So really the ratio of 1 meter to 2 kilometers, it's a 1 to 2,000 ratio, which means it takes 2,000 of these to make one of these. Okay, 1,000 meters to make 1 kilometer, so 2,000 meters to make 1 2-kilometer distance. Here the same thing, I need to convert to the same units, and usually you want to take your bigger unit and make it the smaller one just so you don't get decimals. So 3 yards, I'm going to convert that into feet. So I'm going to times it by 3, so I get 9 feet over 6 feet, and then reduce this to 3/2. Here's an extended ratio, so this is comparing 3 things. It's actually comparing the angles in a triangle. So here's my triangle. I don't know what the angles are, but I know that whatever this one is, okay, so I've got one that is 3 of some quantity. So let's say my base quantity is x. So this angle would be 3 of those x's. This angle would be, I guess I should put 3 in the smaller one. I mean, it really doesn't matter, but just to make it more feasible. This would be 3 of whatever my units are. This would be 4 of them, and this would be 8 of them. Okay, because by doing this, I'm guaranteeing that whatever x is, it doesn't matter because I'm going to have a ratio of 3 to 4 to 8. Now I just need to use what I know about angles in a triangle. I know that they add up to 180 degrees. So 8x plus 4x is 12x plus 3x is 15x. That equals 180 degrees. If I divide by 15, I will get, let's see, 15 goes into, this is 60 times 3. 60 over 15 is 4. 4 times 3 is 12. So x is 12 degrees, which means this angle would be 36 degrees. This would be 48 degrees. And this would be 96 degrees. And that adds up to 180. Solving proportions, you're going to cross multiply. 9x equals 84. Divide by 9. Then you get 9.3 repeating. So 9 1/3. Here you're going to do the same thing, so you're still going to cross multiply, but now we're going to have 10 times the whole numerator, so make sure you use parentheses, equals 4 times s. Distribute. We'll bring the 10 over, the 10s. Negative 40 equals negative 6s. Divide by negative 6. That goes in there 6 times. It leaves 4 over, which leaves 40, and we'll just be dividing by 6 forever. So it's 6.6 repeating, which is the same as 6 2/3, which would also be 20/3. Okay, so that's section 1. I know I did quite a bit here, but really this is a lot of basic stuff that you've seen in other classes, either other math classes, other science classes. And this is the basis for what the chapter's about.